All right, so let's remember for congruent triangles, how did we decide, what were our theorems to decide if triangles were congruent? We had 3 of them, basically. I'll get us started. SAS, side angle side. So what was another way that we could tell if triangles were congruent? Angle side angle, and what was the last one? Side. And hypotenuse leg was a special one for right triangles. We'll do something special for right triangles a little later when we talk about trigonometry, because trigonometry has to do with similar triangles. All right, we're going to do the same thing for similar triangles. And if we remember what side angle side, angle and side let us do is decide if the triangles were congruent without figuring out that every pair of angles was congruent and every side was congruent. So that's what we're trying to do with similar triangles. Do we have some similar theorems? The first one is angle. Now if we remember when we talked about triangles, we said angle did not work to show that triangles were congruent. And I drew a picture like this. And I said here are 2 triangles with the same angles, but that are not congruent. But could those triangles be similar? Yeah. So that's kind of the idea behind this. So in words, what we're going to say for angle similarity is if 2 angles of one triangle are congruent to 2 angles of another, the triangles are similar. Because these 2 triangles look like they're the same shape, right? Well, the angles are the same. One's just stretched more than the other. So there's our theorem. Pretty easy, right? Let's look at a couple of examples. So here are my 2 triangles. And on these questions, all of these questions that we'll ask when we talk about these theorems, are the triangles similar? Are these similar? Well, from the angles that we've drawn there right now, do we know for sure? No, but what can we do? Add them up. Well, all the angles in a triangle have to add up to 180, so we can figure out the third one, right? So which one do we want to figure out? Smaller one? So 90 and 25 is 115. So what does that leave for this one? 65 degrees. So are these 2 triangles similar? Yes, because we have a 90 and a 65 and a 90 and a 65. So that would be yes, similar. Let's look at another one. So here's my first triangle. $105 degrees. 105 degrees. Let's say this one is 45 degrees, and this one is 47 degrees. Are they similar? No. Because if these three angles have to add up to 180, and these three have to add up to 180, can this angle and this angle be the same? No. So these are not similar. They're close to being similar, but not exactly. All right, are we good there? Angle, angle, pretty easy idea. Next one, side, side, side. Just like for congruent triangles, but it's a little different. Instead of the sides being congruent, since we're talking about similarity, how are we going to guess this is going to change? The sides are going to be, what's our big thing for chapter 7? Similar, but how do we tell that they're similar? What's our technique? Proportions. They're going to be proportional. So what we're going to say for side, side, side similarity is we need three sides of one triangle to be proportional to three sides of another. And proportional, what's another way we can think of proportional? What does that mean? When we set up our opener, when we set up the equation, what those two ratios, what's special about the ratios? They're the same, exactly. Means that's exactly right. You just a different way of saying it. They're the same ratio. That's how we tell that things are proportional. They make the same ratio. So all the sides make the corresponding sides make the same ratio. So three sides of one triangle are proportional to three sides of another. The triangles are congruent. Not congruent, similar. So we need to check to see if the three sides, if we're going to use side, 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 for similar triangles, we need to check the sides, all three sides are proportional. Pairs of sides are proportional. So let's look at a couple of examples with this. Here's one triangle. These are not drawn to scale. So again, we want to know, are these similar? What do we think? So we need to, if we're going to use side, 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 we need to check that all the sides are proportional. So let's write, proportional means same ratio. So let's find the ratios. What side am I going to match up with the 5 side? 4.5 or 2.5? Oh, I know what I did wrong. This should be a 4. Is that why you were confused?
Yeah.
All right, now what side am I going to match up with the 5? The 2.5. Why? It's the smallest. Very good. 5 over 2.5 equals 2 over 1. We could write it as a ratio. And 9 over 4.5, 2 over 1. So are all the sides proportional? Pairs of sides? Yes?
No.
So these would be similar. All right, let's look at another one. Not necessarily drawn to scale here. All right, are these two similar? We need to do the same thing, check the ratios, make sure they're all the same. So what side am I going to match up with the 7? 14, why the 14? It's the middle one, right? Middle side. So 7 over 14 is what? 1/2? What are we going to match up with the 5? The 10? And that is 1/2. All right. So they're similar? Right, so we need to check the last one. Oh, let's check the last one. 11 over 24 equals 1/2? No? Does not equal 1/2. So, not similar. We have to check, Iris was right, we had to check all 3 sides. All right. Questions on side, side, side? Okay, last theorem, side angle side. Side angle side a little bit different for similar triangles than it was for congruent triangles. We're going to say if 2 sides of one triangle are congruent. No, I don't want 2 sides congruent, do I? Proportional. Since we're talking about similarity, it's always about proportions. If 2 sides of one triangle are proportional to 2 sides of another, I'm going to underline proportional, of another, and the included angles are congruent, then the triangles are similar. And what do we mean by included? Remember we talked about included angles before? Huh? Right, where the 2 sides meet. So the angle that's between the 2 sides. So if we have 2 sides of our triangle, that angle is the included angle. Where the 2 sides meet. So we need the 2 sides to be proportional and the angle that's between them to be congruent. All right, so let's look at a couple of examples of this, and then we will do one short proof, and then we'll be done. Here are my triangles. All right, I'm going to say this is 7 and 5 and 14 and 10. So for side angle side, are these pairs of sides looking okay? Yes, because yeah, they're half. Our scale factor is 1/2. If this angle is going to be 110, what does this one have to be for them to be similar? What does this say? Sides are proportional and the angles are congruent. Has to be 110. So what if it was 109.9? No. Has to be exactly the same. They have to be congruent. Do you think we should come up with a word for almost similar? Almost congruent? No?
I would just
Add more stuff. All right, another example of with this. All right, so here we have a 35-degree angle and a 35-degree angle. Angle looks okay, right? 5 and 8, 3 and 4.8. Are they similar? What do we have to do? Find the ratios. So what side am I going to match up with the 5 side? And 5 divided by 3 is 1.66 repeating. And 8 divided by 4.8 is 1.66 repeating. So they are similar. And our scale factor is 1 2/3. 2/3, 1 point, 2/3, 1 point, or 666.666, 2/3. Maybe. Yeah? Yeah. All right, are we good there? Yes, I'm sorry? Some, yeah. Yeah, we're doing really good. All right, questions? Okay, let's do a quick proof. We always can use more practice on proofs. All right, so here's our setup. And we want to prove that triangle STL is similar to triangle CLT. And we're given that the measure of angle S is 35 degrees. Measure of angle CTL is 55 degrees. And angle STL and angle CLT are right angles. All right, and we're going to put we'll do a 2-column. So we're not going to rewrite all of our givens. We can use all of those. So looking at this diagram, what theorem, side, 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 angle, side, or angle, angle, do you think we should use? Angle, angle, right? Isn't this like the example we did where we just tried to figure out if the triangles were similar? The same kind of thing. So what other angle do we want to figure out? Angle. Well, we need to give it a better name than just angle L, right? SLT. So we're looking at SLT. So we're looking at this angle. So how do we figure out that angle? Measure of angle SLT equals 180 minus 35 minus 90, which equals what? What do we hope it equals? We hope it equals 55, right? Does this turn out to be 55?
Yes.
Yes? And what would our reason be
Angle bisector.
that we can subtract these two from 180? All angles in a triangle add up to 180. We could call it triangle sum. All right. So now we can say that angle SLT is congruent to angle, what did we call it before? CTL. Yes.
When you read the statement and for the reason, like, are there phrases that you have to memorize, or can you just make up something like triangle
Triangle sum, or several people said because the angles in a triangle add up to 180. You could just say that, and that would be fine. All right. So why can we say these two angles are congruent now? We said their measures are the same. Now we're saying they're congruent. Isn't that what congruent means? Yeah. So this is the definition of congruent. All right, so there's one angle that we have congruent. We need another angle. So what other angles can we say are congruent? Angle C, CLT, congruent to angle STL. And what's our reason there? They're both 90 degrees, they're both right angles. All right, now what can we say? We know the two pairs of angles are congruent in these two triangles. So what can we say? The triangles are similar. Triangle STL, similar to triangle CLT. And what's our reason here? Angle, angle. So nice easy proof there. So we're just doing the problem like the example we did. We're just giving some reasons for everything that we said. All right, questions? Okay.
We're not blaming. Gary.
All right, there we go. Let's get out our